Hello Pre-Calc Excel students, and welcome to lesson 5.3. Today we're going to go over solving trigonometric equations. So you're going to see as we go through these problems, there's lots of different types, and there's two types of instructions. One of the instructions is to find all solutions. Okay, so let's get started. Okay, so when you're solving a trig equation, your steps are similar to what you do in any algebraic equation where you want to isolate, instead of x, you're isolating the sign of x in this case. So we're going to add 1 to the other side, divide by 2. So the sign of x is equal to 1/2. Your next step is to think about the quadrants where the sign is positive. Sign is positive in quadrants 1 and 2. And then you want to think about the reference angle. If the sign is 1/2, then our reference angle is pi over 6. So one answer would be pi over 6. The other answer in quadrant 2 is 5 pi over 6. But when the instructions say all solutions, remember there are infinitely many angles. If I keep going around the circle in either direction, that would have that same sine function value. So we sum that up by adding on a multiple of 2 pi n. Remember, angles that are coterminal differ by 2 pi n. So I have two solutions, pi over 6 plus 2 pi n and 5 pi over 6 plus 2 pi n. For this example, we have cosine squared x is equal to 3/4. And then taking the square root, an important thing to remember is the plus or minus. If you forget that, you're going to lose solutions. So now I'm getting an answer from every quadrant. Right? Cosine is positive in 1 and 4 and negative in 2 and 3. And again, I have the same reference angle in every quadrant. So one thing I could do is take pi over 6, and instead of adding 2 pi n, I can add just pi n. That'll give me all of the solutions in quadrants 1 and 3. I can do a similar thing with 5 pi over 6 from quadrant 2 and add pi n, or n pi, and I'll get all of the angles coterminal to 5 pi over 6 and 7 pi over 6. 11 pi over 6. Now there's even a nicer way to sum it up. I could write it out as plus or minus pi over 6 plus n pi. Okay, so positive pi over 6 and negative pi over 6 again gives me all of those angles from all 4 quadrants. Okay, now here's the other set of directions. Find all solutions in the interval from 0 to 2 pi. Now this problem, when you look at it, it almost looks like it could be a Pythagorean identity, but we don't have any squares, right? So that means we need to square both sides. We can't do any substitution with the way it is. Excuse me. We can't get the equation set equal to 0 and solve for anything, so we're going to square both sides. But remember, when you square both sides of an equation, you can introduce extraneous solutions. So when we are done solving, we need to go back and check our solutions just like you would in an algebraic equation. So when I square the left-hand side, I get sine squared x plus 2 sine x plus 1. And over on the right, I get cosine squared x, and I'm going to do a Pythagorean substitution on the right. Combine my like terms, and then I can factor out a 2 sine x, set each factor equal to 0. So when the sine of x is equal to 0, my solutions are 0 and pi. And for negative 1, my solution is 3 pi over 2. So now we need to check these solutions. Okay, so we want to go back to the original equation. Okay, don't go back to anything beyond that, or they will work. But if we check in the original equation, we'll find out if there's any extraneous solutions. So here's the check. When I plug in 0, I get 1 equal to 1. Makes sense. When I plug in pi, I get positive 1 equal to negative 1. That does not make sense. And when I plug in 3 pi over 2, I get 0 equal to 0. So I have two solutions, right, when x is equal to 0 and when x is equal to 3 pi over 2. Okay, here's another type. These are called multiple angle problems. For this problem, letter D, we're finding all solutions. So notice now we have a sine 2x. So I'm going to move the root 3 over 2 to the other side. Sine is positive in quadrants 1 and 2. My reference angle is pi over 3. So I have the two solutions, pi over 3 plus 2 pi n and 2 pi over 3 plus 2 pi n. But that's what 2x equals. So to solve for x, I need to divide by 2. I'm dividing the pi over 3 by 2, and I'm also dividing that multiple that I'm adding on to my solutions by 2 as well. Here we have a change in instruction. We're going back to the interval from 0 to 2 pi. So if I have cosine x over 2 equals a half, cosine is positive in quadrants 1 and 4. My angle is pi over 3. So I have pi over 3 and 5 pi over 3. That's what x over 2 equals. So think about the interval. If x ranges from 0 to 2 pi, then x over 2 would range from, from 0 to pi. So when I solve, I'm going to multiply both of these by 2. So I get 2 pi over 3 and 10 pi over 3. 10 pi over 3 is not a solution given the instructions that x has to lie between 0 and 2 pi. It's too large. So my only solution is x equal to 2 pi over 3. Another way to think about this, think about the graph. If it's cosine of x over 2, how does the period of the graph change? If you said that it stretches, you're correct. If we take 2 pi and divide by a half, we get 4 pi. So that means that the graph is stretching out, the wave is stretching out. We're seeing less x-intercepts over the interval from 0 to 2 pi. So we're going to have less solutions. Okay, here's another new instruction. Using inverse functions, we're needed to find all solutions. So where needed means if your answer can still be one of our common angles, then you would give it as the common angle. So we only use the inverse functions for solutions when it's not a common angle. So keep that in mind. So here I have 4 tangent squared x plus 5 tangent x equals 6. It's a quadratic. We're going to use those skills you learned in section 1. We're going to move the 6 to the other side, and we're going to factor. So this factors into 4 tan x minus 3, tan x plus 2. Setting those factors equal to 0, I get tan of x is equal to 3/4, and the tan of x is equal to negative 2. So I have a positive solution, and I have a positive ratio, and I have a negative ratio, which means I'm going to have solutions in all 4 quadrants. So my first solution, I'm going to label them x sub 1 through x sub 4, and next to them I put the quadrant that they lie in. So my first solution is from quadrant 1, and it's just the tangent inverse of 3/4. And this is actually my reference angle. I'm going to use this to write out the rest of my solutions. Well, I only have one other solution where I'm going to use this. So in quadrant 3, the tangent is also positive, and to get that quadrant 3 angle, I take pi and I add on the reference angle. So again, think of tangent inverse of 3/4 as the reference angle. When the tangent is negative, if I take the tangent inverse of a negative, and you can try this on your calculator, it's going to give you the negative reference angle. If I take the tangent inverse of positive 2, then you'll see that you get the positive reference angle. So here again, that's what I prefer to work with. So I'm going to have solutions this time in quadrants 2 and 4. To get the angle from quadrant 2, I'm going to take pi and subtract the reference angle. So again, think of the tangent inverse of 2 as the reference angle. The angle from fourth quadrant, I'm going to subtract the reference angle from 2 pi. So it's 2 pi minus tangent inverse of 2. So there's an example of how you write out your solutions using inverse functions from 0 to 2 pi. Okay, same instruction for this one. So we have the sine of x equaling negative 1/4 and the sine of x equaling 2/5. So again, we're going to have solutions from every quadrant. So working with this one first, I've got quadrants 3 and 4. So when I take pi and I add the sine inverse of 1/4, that's giving me the quadrant 3 solution. I'll put that off to the side here. When I take 2 pi and I subtract the tangent inverse of 1/4, this is giving me, let's see. Oh, wait a minute. Why did I say 3 and 4? Oh, wait, I'm sorry. This is sine. So, okay, we're good. We're good. Okay, so yes, sine is negative in 3 and 4. The quadrant 4 answer is 2 pi minus sine inverse of 1/4. For a minute there, I was thinking I was still doing tangent. Sorry about that. Okay, now the two positive solutions come from quadrants 1 and 2. So for quadrant 1, that's always the easiest one to work with. It's just the sine inverse of 2/5. For the quadrant 2 answer, I'm going to take that reference angle and subtract from pi. So this is the quadrant 2 answer. So again, I like working with the positive reference angle. You don't have to. You certainly can work with the negative angle. In other words, for this one in quadrant 3, I could say pi minus the sine inverse of negative 4. The sine inverse of negative 4 is going to be a negative reference angle. And if I subtract the negative reference angle, it's the same as adding to pi. So there's a lot of different ways that these can be written out, but I find it easiest to work with the positive reference angle. Using the calculator. Okay, so, and now again we're doing solutions from 0 to 2 pi. So the tangent of x is equal to negative 3. When I take the tangent inverse of negative 3, I get this negative reference angle. I know again with tangent I'm going to have solutions in quadrants 2 and 4. And you might be saying, okay, well there's the quadrant 4 answer. This is in quadrant 4, but it's not within this interval. So it's not a valid solution to give with these instructions. So here's what we can do. We can take our calculator, and because of the fact that the tangent has a period of pi, I can just add pi onto this angle, right? So I'm adding pi, and that's going to give me the quadrant 2 answer. So that negative reference angle plus pi gives me 1.893. And when you're working with the decimals, always think about, does it make sense? Or pi over 2 is about 1.57. Pi is 3.14. So my angle falls within there. Sounds good. Okay, the second solution. I can just add pi again. Okay, come back around to my quadrant 4 answer. So on my computer, I'm not clearing my display at all. All I'm doing, I took the tangent inverse of negative 3, I added pi, got that angle, and added pi again. So I'm not doing any rounding. I'm getting accurate answers. And 5.034 makes sense, right? That's definitely in quadrant 4. Okay, let's see. Here we have a quadratic, but it's not factorable. So guess what we have to do? Pythagorean quadratic formula. Okay, but instead of x equaling our quadratic formula, it's the sine of x. that equals this. So we're going to calculate -4 plus or minus the square root of b squared minus 4ac all over 2a. Now when you're doing this, don't even worry about simplifying the radicals. Right? We want a decimal. So just plug that in, -4 plus or minus, well, start with -4 plus root 32 and divide that by 8. That gives me this sine function value right here. Now, I'm going to go back in my calculator. If you have a newer calculator, you can hit your up arrow, go right back up into that work, change the plus to a minus. You don't have to type all that in all over again. When I change that to a minus and then divide by 8, I get this value. If you have an older calculator like I do, you can hit second enter and keep hitting second enter until it brings you back to the line of work, this line of work, and then you can change the sign. So there's a calculator tip for you. Okay, now again, these are function values. This is where it gets confusing because they look like they could be angles, right? But at this point, we still have a function value. So I need to take the sine inverse of 0.207. And look at the angle, it's almost the same. It's 0.209. So again, keep your work nice and neat and organized so that you remember everything labeled, right? That the sine of x equals this. This is not the x value yet. This is the x value. This is the angle in radian measure. Now I also have a solution in quadrant 2. So I'm taking pi minus x1, or minus the solution, and that gives me this angle, right? Because remember, this is our reference angle from quadrant 1. So when I subtract that from pi, I get my angle in quadrant 2. That's also a solution. Now you might be saying, hey, wait a minute, what about the rest of the problem? If I have -1.7, or I'm sorry, -1.207, can the sine of x equal this? No, right? The sine function values and cosine function values, for that matter, have to be between -1 and 1. If it's outside of that range, we get no solution from this. But you don't have to write no solution. We have 2 solutions. We just don't have any more solutions. We're not going to get 4 solutions like we might with the tangent function. Okay. So that's a good variety of problems in different kinds of directions. We'll do more in class. I hope you enjoyed the lesson and have a good day.